ladies and gentlemen.
Welcome everyone. Let's talk dividing polynomials. So with division of polynomials, we have two major ways to do it. You may have been taught a third if you've used the area model or the box method to divide, but the two major ones that are generally applicable and are quick would be long division and synthetic division. So let's talk about each of those. So long division works very similarly to long division with numbers. We're going to set it up in a very, very similar way as well. So what I'm going to do is I'm going to take my division here, and I'm going to write what I'm dividing by on the outside. So x plus 4. I'm going to make our division symbol. And then inside, we're going to put what we are dividing, which is the x squared plus 7x plus 15. Now, when we go about this, we're kind of asking ourselves a question consistently, and that is, how do I turn the first term, this x, into an x squared? Well, the answer to that at first would be to multiply by x. So what we're going to do is we're going to distribute this x into all parts of what I'm dividing by. So x times x is x squared, x times positive 4 is positive 4x, and then we are going to subtract this. So I'm going to subtract the entire thing. So when I subtract, I'm going to distribute that subtraction so that I know exactly what's going on. So we are subtracting this 4. So x squared minus x squared is 0. And then 7x minus 4x is 3x. And it's going to be positive because the 7 was positive. Then we're going to bring down this 15. So plus 15. And we're going to ask ourselves the same question that we did before. How do I turn this x, what do I need to multiply this x by to get 3x? That would be a 3. So I'm going to distribute that 3. 3 times x is 3x. 3 times 4 is 12. And we are going to, a positive 12, and we are going to subtract this. So distribute that subtraction, and we get 3x minus 3x, which is 0, and 15 minus 12, which is 3. So this means that when I divide x squared plus 7x plus 15 by x plus 4, I get x plus 3 with a remainder of 3. That it's depending on the context, that might be all you need. If you are representing what is the result of this division, you would write it out as x plus 3 plus, our remainder was 3, so 3 divided by, and then what we were dividing by, so x plus 4. So this is the result of this division. Hopefully not too bad. Synthetic is nicer. It's very much more of an algorithm. Well, they're both really algorithms. But synthetic is unique in that it only works if you divide by a linear factor. Long division, it doesn't matter if you are dividing by a linear, a quadratic, or a cubic. It really doesn't matter at all. But for synthetic, you have to specifically be dividing by a linear factor. So the first thing that we're going to do is we're going to set that linear factor, that x plus 4, equal to 0, and we're going to solve. We can easily see for this one that the solution would be x is equal to negative 4. We're going to take that negative 4, and we're going to put that negative 4 in a box. Next to that box, we're going to write out the coefficients, the multipliers, the number being multiplied by each term here. So the x squared has a coefficient of 1, the 7x has a coefficient of 7, and the 15 is just 15. And then we're going to draw a nice line underneath, giving ourselves some room. I know, bear with me. What we're going to do from here is we're going to drop down the first number always. So we're going to write down a 1. And then every time I move up, every time I move diagonally up, I'm going to multiply by what's in the box. So 1 times negative 4 is negative 4. If I add those together, I get 3. And then I'm going diagonally up again. So I'm going to multiply that by -4, which gives me a -12. Add those together, and I get 3. And we're going to put that last number in its own little box. And hopefully you can see that we get something very similar to what we had before. We have a 1, we have a 3, and then we have a 3. So this actually translates to x plus 3 with the remainder of 3, which we could also just write as plus 3 over x plus 4. So it doesn't matter how you do the division, it ends up exactly the same. Now, here's another thing to note. We had all of our terms for both of these. So we had, if we start with the quadratic, we have the quadratic term, the linear term, and the constant term. Same thing here. If we're ever missing one, you have to make sure that you write that term with a 0 next to it. So if I was missing the linear term, I would write 0x, which I would replace the 7 with a 0 there, or I would put a 0x with my long division here. So let's do a slightly harder one for both. So again, we're going to do the exact same one 2 different ways and see what happens. So first thing I'm going to do is I'm going to rewrite this. So 3x minus 2, division symbol, and then 6x cubed minus 7x squared plus 11x plus 1. It's also important that this is in standard form, descending order of powers, just so we don't get confused on where our terms go. So, long division, we're going to ask ourselves what times 3x is 6x cubed. That would definitely be a 2, and I have 1x here and I need 3x's, so I need to multiply that by x squared. So 2x squared, I'm going to distribute. So 2x squared times 3x gives us our 6x cubed. That's why we did it. And then 2x squared times -2 is -4x squared. We are going to subtract these. So 6x cubed minus 6x cubed is 0. And when I distribute that subtraction, this actually turns into a plus. So we have -7x squared plus 4x squared gives us a -3x squared, because the absolute value of -7 is larger than +4, we get the sign of the -7. Then we're going to drop down this plus 11x, and we're going to continue to ask ourselves the exact same questions that we were asking before. What times 3x is -x squared? Well, that would be a -3x squared, my bad. That would be a -x. So we're going to distribute that -x. We get -3x squared plus 2x. And we are going to subtract these. And you just follow this operation all the way down. So when we subtract these, we are distributing the subtraction here. And that gets us 0. 11x minus 2x would be a 9x, positive. And then we can drop down this 1. And then we're asking ourselves that same question for the last time, which is what times 3x is 9x, and that would be a +3. So distributing that 3, we get a 9x, we get a -6, and we are subtracting this. Distributing our subtraction, and then combining. So 9x minus 9x is 0, and then 1 plus 6 is 7. So we have a +7 as our remainder. So what is the result? The result would be 2x squared minus x plus 3 plus 7 over 3x minus 2. Not awful, but very, very long and tedious. This is why I like the synthetic. So, same idea for the other synthetic. We're going to set the denominator equal to 0. So 3x minus 2 is equal to 0. We solve this. We get 3x is equal to 2 by adding 2 to both sides, and then divide by 3 to get x is equal to 2/3. So we have a fraction here, and that can get a little scary. So Just keep that in mind. So 2 over 3 goes in its own little box, and then we get 6, -7, 11, and 1. We're going to go about this the same way we did before. We're going to drop the first one down so we get a 6, and then we're going to multiply it by what's in the box every time we go up and to the right. So 6 times 2/3. 6 divided by 3 is 2, times 2 is 4. -7 plus 4 is a -3. I'm going to multiply that by 2/3. -3 divided by 3 is -1, times 2 is -2. Add these together, we get a 9. Going to bring that up, so 9 divided by 3 is 3, times 2 is a 6. Add those together, we get a 7. So, seemingly, we get something different. Look at what we have here, and then what we have here, and what's different about them. Well, the 6 is 3 times larger than 2. The -3 is 3 times larger than the -1, and the 9 is 3 times larger than 3. So why am I getting an answer that's 3 times larger? Well, it happens to do with the denominator of what's in our box, the denominator of what we solved for. We're going to divide all of these by that denominator. So we're going to divide all of this by 3. Not what's in the box, only what divided nicely. So that gets us 2x squared minus x plus 3 plus 7 over, and that was 3x minus 2. So that rule might be a little bit confusing, and it's kind of a one-off. You have to memorize that part too, and it doesn't come up as often. So there are some people, some of my students, who love to use the synthetic division for simple linear factors, and then switch to long division when it's something that they just aren't quite sure of, and that's perfectly fine. My goal with this was to give you 2 tools for your tool belt so you have the option to switch and use whatever you're most comfortable with. That's it for this. So good luck on any practice. If you have any questions, let me know. Otherwise, I'll see you in the next video.